In today's tutorial, we're going to be creating this particular recursive subdivision loop, but we're going to make it sci-fi. If you haven't checked out my original recursive subdivision loop video, definitely check that one out, although we will be going through it really quickly in this video. So with that, let's begin the tutorial. In our default scene, we'll bring our cursor to the junction of these two windows, click and drag to create a new window, and then change this from the 3D viewport to the geometry node editor. Then we'll press this plus button to create a new geometry node tree, zoom in, select the group input, and tap X to delete the default cube. Now we'll press Shift A and search for a grid node, which is going to be the basis for our recursive subdivision. Now we can plug that directly into the group output and change the size to 10 meters on both the X and the Y axes. Next, we need to actually subdivide the grid. So we'll search for a subdivide mesh node and plug that in, and we'll increase the levels to 2 for the initial subdivisions. If we want to see how much this is being subdivided, we can switch on wireframe view to actually see the subdivisions. So if you increase it, this is how it looks, but we'll start off with 2. After that, we'll go ahead and press Shift A and search for a separate geometry node and plug that in after the subdivide mesh. And for the selection, we'll press Shift A and search for a random value node and change this from float to boolean so that a random number of them will get selected. If we plug this into the selection, we see that many of these faces have just been removed. But along with that, the edges have also been removed. So we have to make sure that we change the separate geometry from point to face so that either the entire face is removed or the entire face remains. Now, once we have this, we obviously don't want the rest of it to just be deleted. We want it to remain, and it's present in this inverted socket. So we can search for a join geometry node and plug the inverted into the join geometry as well so that we get the entire grid. Now for the faces that were selected in the separate geometry node, we can subdivide them again. So we'll search for the subdivide mesh node, press Shift D and plug that in over here. Next, we can give this one more layer of subdivisions by just duplicating all of these nodes and doing it again. So we'll take this separate geometry, random value, subdivide mesh, and join geometry, and then press Shift D to duplicate them and bring them to the side. Next, we'll take this group output, shift it over, and press Ctrl right click to remove the connection. Remember, for Ctrl right click to work, you need the Node Wrangler add-on switched on. So I highly recommend going to Edit, Preferences, going to your add-ons and checking Node Wrangler. Next, let's connect the join geometry to this separate geometry and plug this into the group output. Now, I don't want there to be this much subdivision on this second version, so I'll reduce the level down to 1, and this is what we have. Next, we can go ahead and actually extrude these faces. So to extrude these faces, we'll switch back to our solid view and then search for an extrude mesh node and plug that in after the join geometry. Now we want to make sure that the individual is checked, and for the offset scale, we'll control it using a noise texture and a wave texture. So let's search for a noise texture first, and we'll change this from 3D to 4D so that we have this W slider for selection, and then we can plug this factor into the vector of a wave texture. So let's search for a wave texture, and now the color of the wave texture or the factor of the wave texture can go into the offset scale. To animate this, we'll later on use the phase offset of the wave texture to get this particular motion, and we can make it perfectly looping by making sure that the differences in the value is equal to 2 pi or a multiple of 2 pi. Now, I personally believe that this is way too tall and I don't want it to be this high. So to reduce the height, I can search for a math node and plug that in over here and change this from add to multiply and just multiply it by a value of 0.5. Or if I think that's still too high, I can reduce it down to 0.2, but I'll keep it at 0.5 for now. In case you want to actually increase it even more, you can always multiply it by a large number, and that increases the height even more. And maybe this could be your city or something like that. Anyway, after we've created this, we want a few of these blocks to have some wireframe that moves up and down along with this, but with some offset. So to create that wireframe, we can again move this group output to the side, press Shift A and search for a join geometry node so that we can have both the blocks as well as the wireframe. And then we can extrude not every single one of these blocks, but only a few of them. So we go to this join geometry here and use a different extrude mesh node. So let's bring this here and search for an extrude mesh. And for the selection, we can use another random value node. Remember, for all of these random value nodes as well, you can always play around with the seed to just give it some more randomness. Now let's take this random value, press Shift D and plug it in here, and we'll change the seed value and plug the value into the selection. So you can see that firstly, they're all the same height. So we have to make sure that the offset scale uses this same value over here so that it is the exact same as the original that we had over here, except a few of the faces are not extruded. If you look at this, every single one of the faces are extruded, and if you plug this one in, just a few of them go straight back down to 0. However, I still don't want so many of them to be up, so I'm going to reduce the probability from 0.5 to 0.25, and that way even fewer are selected. Now to convert this into a wireframe from a mesh, we can search for a mesh to curve node and then change this curve back to a mesh by searching for a curve to mesh. And for the profile curve, we use another curve circle and we can plug that in. Now, obviously, there are many issues with this. The first being the radius is way too large. So I'll reduce the radius to 0.005 and that looks like a nice wireframe. If we even switch off overlays, you can see what the wireframe currently looks like. If you feel like it's still too fat, you can always reduce the radius further to make it even thinner. Now, because it's so thin, we don't need this resolution to be this high. So we'll reduce the resolution down to something like 10 and there will be no noticeable difference, but it'll be much faster when you actually render it out. You could reduce the resolution even more as well based on your preferences. Next, since we want both of them present together, instead of plugging this into the output, I'll plug this into the join geometry and take the output from the join geometry into the group output. Now, if you actually look closely, on top of the cubes, there is a wireframe present. If you want to see this better, you can actually switch on cavity and that way it just pops even more. Next, we don't want this to be perfectly seated right on top of the other mesh. We need to give it some offset. So to give it some offset, what we'll do is we'll actually scale them up on the z-axis. So to scale these, you could search for a transform geometry node, but the problem with the transform geometry is that the scale is a round socket, which means all of them are going to scale up and scale down by the same amount. We need them to scale independent of each other, so we can't use a transform geometry. The only way we can change them separately like that is by using a scale instances node, because if we use a scale elements node, it's going to scale everything uniformly because this is a gray dot, which means it takes a float value. We want it to scale up only on the z-axis, so we use a scale instances node. But the problem is this currently is not an instance. It's actual geometry. If you plug this in, you see it gets this little warning which states that realized data is ignored. So to fix that, all we have to do is search for a geometry to instances node and plug this right after the curve to mesh. Now, since we want to scale it up only on the z-axis, we can search for a combine xyz node so that we have control over each of them separately. And for the x and y, we'll keep the values at 1. However, for the z, we can use this same value from here, except we add in some offset. So we can press Shift A and search for a math node, which is going to be kept at add itself because we're adding in some offset. So let's plug this into the first socket and take the output of this add value and plug it into the z of the combine xyz. Now, if you take a look at it, many of these wireframes have come below the actual mesh, and if we play around with the phase offset of the wave texture, you can see that there is some sort of a motion, but there's no situation where it comes above the mesh. So to do that, we can either increase the value on the add, so let's increase it to maybe 1, and then when we play around with the phase offset, there are situations where they are coming above the mesh, and I think that looks good enough. But in this situation, there's no situation where they go below the mesh. So to fix that, after the add, I'm going to use another multiply node. Let's change this from add to multiply and just multiply it by a value of 0.9, and that way they do come below the mesh as well. And you might want that, you might not want that, it's up to you, but I think I'm going to keep it like this, maybe go down to 0.8 itself. So now when I play around with the phase offset, we should have situations where they come above the mesh and we have situations where they come below the mesh as well. So next, we need to actually deal with the materials. So let's assign materials, and we actually require 4 materials. One for all of the wireframes that we created, one for the top faces, one for the side faces, and the last one for specific top faces which will not be lit up. So we need to create 4 material slots. So let's go to the material tab over here and press this plus button 3 more times to create 4 slots. And now we'll change the name of material to maybe wireframe. Next, we'll click on the second slot, add in a new material, and this one we'll call top_lit. The third one we can call sides. And for the fourth one, we can go ahead and just leave it as is for now, because once we create top lit, we'll just duplicate that one over here so that it's not a big hassle. Now let's press Shift A and search for a set material node and plug that in after the extrude mesh. Now this I want for everything together, so I'm not going to choose selection and just choose top lit from here. Now I could use the top selection, but it won't make too much of a difference because I will be selecting things for the side after this and for the few that won't get the top lit material and will get the top non-lit material. So we don't need the selection, but it's fine even if you keep it. Next, we'll select the set material, press Shift D, and this one we're going to call sides, and we're going to take the side selection and plug that in over here. Next, we'll take this set material, press Shift D and plug it in over here. And now we're going to use the top selection, but we want not just the top, we want the top plus a few extra conditions so that not all the top faces are selected. For that, we can take this same Boolean random value node, press Shift D, and so only if this random value gives a value of true and it's also top, only then should it get this top lit material. So let's press Shift A and search for a Boolean math node so that we can take care of that operation. And we need it to say yes on both this random value and the top. So we're going to keep it on and itself, so that if this is saying true and the top is saying true, then it gets this material, which is not going to be top lit, but it's going to be top not lit. So we'll just press this X button to remove it for now, and we'll add it in once we actually give it the material. So now let's actually set up all of our defaults and then start with the texturing. So let's go to our render properties, switch on ambient occlusion, expand it, increase the distance to something like 10, and then switch on bloom. We're going to expand this and we'll clamp it down at something like 10 and reduce the intensity to 0.02. Then we'll switch on screen space reflections and go to the output properties, where we'll change the frame rate to 30 frames per second. End frame will keep at 150 so that it's a 5-second long animation. Output folder can be wherever you want it to be. File format, we're going to choose FFmpeg video. Encoding, we're going to have to change the container from Matroska to MPEG-4, and output quality I'll keep as perceptually lossless. Then I'll change my viewport display to rendered so that we can actually see what changes we're making, and I'm going to select the default light and press delete to remove it. Next, I'll place my camera where I want the final camera to be, so I'll just position myself in a desirable view and then press Ctrl-Alt-0 to snap camera to view, after which I'll select the camera, go to the camera properties, expand viewport display and increase passport out all the way to 1 so that nothing outside the camera view disturbs me. Next, I'll go to the object properties over here and just make these locations to what seems to be right. I want Y location to be 0, and for the rotation I want it to be 0 on the Y axis and 90 on the Z axis. So that way we know that it's all aligned up perfectly well. Now of course you could play around with the X axis a bit and the Z axis location and things like that just to make it into a better composition, but for now I'll leave it like this. I might play around with that just before the final render. Similarly, you can always select this in the geometry node section and play around with the random values till you get something that you think looks a bit better. So maybe I'll just go with this for now. Next, let's actually change from the geometry node editor to the shader editor and start with the materials. So first we'll deal with the wireframe. So let's go to our material properties and choose wireframe. Over here I don't want it to have a principled BSDF, so I'll press X to delete it and then press Shift A and search for an emission node. Now I simply can plug this into the surface and change the color to maybe an orangish color and increase the strength to something like 100. Now I don't see any changes because I did not assign a material to the wireframe, so I'll quickly go back and do that. Let's go to the geometry node editor, go down to this branch over here, take this set material, press Shift D, plug it in here and choose wireframe from this drop down. Now the wireframe has that emissive material and this is what it looks like. Now we can go back to the shader editor and continue playing around with the sides material. So let's select sides. I'll keep it at principled BSDF itself. I'll increase the metallic all the way to 1. I'll leave the roughness at 0.5 and I want there to be some horizontal lines that are emissive. So I'll press Shift A and search for a Voronoi texture and I'll change this from Euclidean to Chebyshev. Next, I'll reduce the randomness all the way to 0 and I'll press Shift A and search for a color ramp node so that I have more control. So then I'll plug the color into the factor and change this from linear to constant and just bring this in by a bit, and I'll search for a math node so that I can make the emission grow far greater than 1. So I have to plug this into the first socket, and for the second socket I have to change this from add to multiply and multiply it by maybe a value of 10. Now if I plug this value into the emission strength and I give it some emission color, I should be able to see some changes occurring to the sides. So let's make this a bright color and make it maybe this sort of a blue. Now everything seems to be lit up, so evidently there's something with this setup that isn't working. So the first thing that I could do or try is increasing the scale of this Voronoi texture, and that seems to be working. So let's increase the scale to 50, and then I need far more black regions. So I'll just increase this to something really high and that looks fine. Now I feel like we just have a few lines of blue in this orangish wireframe, and I'll keep it like that itself. Maybe increase the value even higher, make it 30 or 100. Next, we need to play around with the top material. So let's switch over to top lit from here, and first we'll give it some texture. So I'm going to use a Voronoi node and I'm going to change this from Euclidean to Chebyshev, and I'll plug it into a color ramp so that I have more control, and I'm going to use the color value this time. Next, I'm going to change this from linear to constant itself, bring this value in for now. I'll be changing this in a second, but I want to use this color to play around with the roughness of the top surface. Beyond that, I also want it to be completely metallic, so let's increase this all the way to 1. And if I play around with the scale of the Voronoi, I should be able to see the texture come in. So maybe I'll go with a size of 50, and then since I don't want any region to be completely non-reflective, I'll change this white to a value of 0.8, and I don't want anything to be completely reflective, so I'll change this black to a value of 0.2. Next, I'll add in another stop by control clicking, and this one maybe I'll give it a value of 0.5. Now that we have this set up for the roughness, I also want this to act as a bump. So I'll press Shift A and search for a bump node, plug the color into the height and plug this normal into the normal. Now I think that looks good enough for what I wanted to do, but this still has one issue. We have to actually animate it to see the issue. So what I'll do is I'll just create a new window and change this to the geometry node editor so that we can actually play around with the values before we animate it, so that you can see what the issue is. If we were to go to the wave texture, which is what we're going to use to animate it, and we play around with the phase offset, you can see that this actual Voronoi texture changes, and that's because the Voronoi texture is in 3D and not mapped to the object or these individual instances. Now you could fix that by using UV coordinates, but these do not have a UV texture unwrapped, and unwrapping it is an issue or at least it's a hassle in my opinion in geometry nodes. So a workaround is simply changing this from 3D to 2D, and that way it no longer takes depth into consideration. And now if you play around with the Z axis, it's going to remain exactly as it is. So that is just a quick fix to this, and I think that'll work well enough for what we're trying to do. I'm also going to increase size or scale to 75 so that we just get a little bit more variation. The next issue that we have to fix is that this is actually the top lit material. That means we want these areas to light up when they're crossing a specific height. So to play around with that, we can use a gradient node and a color ramp and plug that into the emission strength of the emission socket. So let's initially take this gradient texture, plug it into the factor, and Control Shift click to see what we have. Of course, again, Control Shift click and all of these shortcuts are Node Wrangler add-ons. So in case anything that I say does not work, make sure you have Node Wrangler enabled. Now, if you look at the gradient is starting from this side over here and moving that way. That's not what we want. We want it to be on the vertical axis. So we can select gradient texture, press Ctrl T, and now we'll rotate it on the Y axis by 90 degrees. And now the gradient is actually present on this vertical axis, but we don't currently see it. So to see it better, what we'll do is we'll just change this from linear to constant for the time being, bring this slider in, and now when you play around with this X value, you can see that the gradient is present at maybe this sort of a height. If you go to 1 to go into your front view, maybe the gradient is at this height. So anything above that height will become white, and anything below that height becomes black. So hopefully that makes sense. So you can play around with this X value. So if you reduce the X value, more and more of it becomes black because the gradient is going higher. And if you increase it, the gradient starts going down, and eventually you'll reach a situation where everything is going to be white. So I'm going to keep it at some arbitrary amount. So maybe just about there. And now I'm going to change this from constant back to linear. And I'm going to go to this end, Control click to add in a new stop and make this black. After which I'm going to bring this black value in as well. And again, I'll just add in another stop here and make this completely white. Now this is what we have. So if you were to animate it now, which we'll again see with the face offset, you'll see that some of them light up and they eventually go off. So that is every time this face crosses that height, it's going to light up. Hopefully you understand what exactly is happening. So that is what we have. Now I don't want this to light up as black and white. I want it to have some color. So I'm going to plug this into the emission strength. And of course, to make the strength go greater than 1, I'm going to press Shift A and search for a math node and set it to multiply and multiply it by a really high number. Maybe we'll go with a value of 100. And for the actual emission color, I'll give it that orangish color that we gave these wireframes. So let's go ahead and choose that orangish color. Now to see it, Control Shift click the principal to BSDF, or you can directly connect the principal BSDF to the material output. Now this is what we have, and if we play around with the face offset, you can see how it moves. Now the issue is that if all of them light up, I feel like it becomes slightly overpowering. So to reduce that, we need a few of them to not light up, and that's where we're going to use the top non-lit material. So now that we created the top lit material, we can select this material slot, go ahead and choose top lit, and then press this button to create its own user, and now change this from top lit 001 to top non-lit. And once you've done that, you can go to your geometry node tree, and for the material socket that you had kept unselected over here just before the join geometry, you can go ahead and choose top non-lit, and that way a few faces will not be lit up, but we actually have to change it to make them non-lit. So to play around with that, all we do is remove this entire emission strength connection and make the strength 0. So once we make the strength 0, all the cubes that have non-lit selected, they will not light up. If you want to increase the number, you can go ahead and increase the probability. I'll change that to 0.75, and that way even fewer of them actually light up. So now by playing around with this face offset, you get the really cool sci-fi animation. You can press 0 to go back to your camera view, and now we'll actually deal with the animation. So on frame 0, we'll change the face offset to a value of 0, and we'll tap I, and then on frame 150, which is the last frame, I'll change the face offset to 2 star pi, which is 1 full rotation, and then I'll press I. Then we'll select this node, and when you select it, the keyframes should appear on the timeline. So you can select it and then press T linear so that it becomes a smooth loop instead of a Bezier loop where it slows down at the start and slows down at the end. So now when you play the animation, this is what we have. Now, of course, this looks good, but I think to make it more sci-fi, it's best you go to the world properties and actually reduce the color even further down to make it much darker. And with that, you get this particular sci-fi wireframe loop using the concept of recursive subdivision and very basic shader nodes. So if you're happy with everything, you can go ahead and press render animation. I really like this type of animations, so So I'm really happy sharing them with you as well so that you can create your own variations, add in your own twists, your own colors, and of course play around with the textures as well to create something absolutely unique, because I really hope that I'm able to explain my ideas well enough for you to understand why we're doing what we're doing. If you have any questions or queries, or there were issues that you didn't understand why we did what we did, please comment them down below so that I can respond to them and help you out, and along with that improve my tutorials so that they cater to everybody. I release one tutorial every single day, so I'm sure there are videos on my channel that you might find extremely useful and informative. Until the next video comes out tomorrow, thank you so much for watching, keep creating and stay creative.